of the talk is as follows. As I mentioned, I will be introducing state a little bit and also mixed data a little bit. The reason for using mix stands for multiple indicator cluster survey. I will speak a little bit more about it later. The reason for using mixed data is that it's not really new, but in the field of economics, there are many topics that are emerging that use micro data sets to study behavioral, psychological patterns that emerge in developing country context. Previously, data for these kind of indicators were not really available. Demographic and health surveys and multiple indicator cluster surveys have actually provided very rich data sets that can be used to analyze several demographic questions that require attention, especially in developing country context. So I will explain a little bit what mixed data entails. I'll show you the table of content just to give you a flavor of what to expect in this data set. Then some of the basic features of Stata Software, what are the advantages, what are the disadvantages, and some of the features to import data, save data, and so on. Basic statistical analysis is grayed out. Initially, I included it, but I think we will not have enough time to do that. The intended outcome is once we are done with this session, I expect our participants to know a little bit more about Stata. So when you see the Stata screen anywhere, you'll know, okay, this is a Stata screen. I have seen this. I'm familiar with that. And what are the different components of it, and how to access data, how to manipulate it. You will know about this, hopefully. And then you will know a little bit more about multiple indicator cluster survey, what kind of data is available, how does it look like, how what kind of measures you should take before actually using it for analysis and so on. And in the end, like how to combine the two things together, how to use this data to actually manage mixed data and use it for analysis. So that is the whole point of this talk. So multiple indicator cluster survey data sets are freely available. So this is the website where you can go, and you have to make a free account on that website using your personal email account. And you have to send them a couple of line research objective, like what is the purpose for downloading this data set. And in a couple of days, they grant you access to this rich data set. So this is a screenshot that you see on your screen right now. In this one, I just used the drop-down menu for country and typed Pak. So it gave us data sets available for Pakistan. You can do that also for India. I will show this in the next screen. I know that most of the audience is from India. On the very right-hand side column, you can see data sets available and not available. So if you see available, it means that if you have access, if they have granted you access to it, once you click that, you will download a zipped file, and in that there will be some files. I will explain it to you in coming slides. So this is the layout you will see in the MICS website when you actually access it, and with it has data for many countries, and so you can download it for whichever country you want. Unfortunately for India, we do not have recent data sets. And also you can see on the right-hand side, data is not available. This has been the case for us as well. When I was working for the World Bank, we were doing analysis for the South Asian countries, and getting data for India was a bit tricky. Indian government is a little bit careful about sharing data, so it's not freely available to everyone. But if mixed data is not available, you have a very good alternative, which is National Family Health Survey, NFHS. It is a very rich data set, and I think you can request them access it. For other countries, this is called Demographic and Health Survey, and for India, it is a little bit customized version, very rich, lots of observations and so on. So maybe that's why they have discontinued mixed surveys after 2000. So if you're interested in exploring Indian data sets for similar topics, you can use NFHS survey. The skill set that we will use today will be applicable to NFHS as well. So if you understand how to merge data, how to append data, how to drop variables, rename variables, and so on, same statistical methodology will be used, can be used for NFHS data as well, because they use similar data structure and so on. So once you download the zip file and unpack it on your computer, you will see these files. In the screenshot, you can see ch.sav and so on. SAV is actually the extension for data file for SPSS. So we are going to use Stata. So this is a very special case for using SPSS files in Stata. Most of you will not need that, but I will show you how to actually use these files in Stata. There are actually two methods of doing it. Okay, before I go to methods, what is the meaning of the file names ch, hh, hl, and so on? You can see in the table below. HH stands for household data set. So at household level, are they using pipe water system? Are they using improved sanitation system? What is the wealth category? Is this house located in urban area, rural area? All this kind of information will be in a household data set. CH stands for child data. So was child sick in the recent past? Does child have all the required vaccinations as per WHO recommendations and so on? All this child-related data will be in CH. WM is for women's data, and so on. So all these files are explained in the table below. Not all of the data sets have all these files in the table below. So for example, some data sets, for example, fg.sav, this is particularly available for African countries. So depending on the country you're analyzing, you will see different combination of files, but most commonly used are the HL, HH, CH, and WM files. If you are using Stata 16 onwards, there is an option to directly import SPSS file into Stata. So you simply go to File, then go to Import, and inside Import, you have this option of SPSS.save data. You click it and then navigate to the folder where that .save file is saved, and then you bring it inside Stata. So I'm not going to demonstrate it right now because most of you will not need it, but this is very simple. You just navigate to the file, the ch.save file, for example, you click it and Stata will bring it to the data set. Alternatively, if you have SPSS, you can open the .save file in SPSS and save it as .dta file. .dta is the extension for Stata dataset or data file. So you can open this SPSS file in SPSS and save it as .dta file. This is also possible. What happens if you open this file using a Stata menu is sometimes the value labels get lost. So more on value labels later, but I will give you an example. For example, if the question is, do you smoke or not? So yes means 1, no means 0. So if original data set in SPSS has yes and no as labels for 0 and 1, when you import it into Stata, it might only show you 0 and 1, not yes and no labels of those numbers. So it requires a little bit more effort to reassign those value labels to the data. But so this is what you need to keep in mind. If you do this directly from SPSS, there is less likelihood of this happening. But yeah, recent versions of Stata has this option, like in importing SPSS data directly into Stata. So just very briefly, I will go through these indicators that are available in MICS, just food for thought. There are several indicators that you can use for your economic analysis, going away from the traditional economic analysis that we usually see. Child nutrition status, child health status, water and sanitation excess of the household. Then you can correlate this with child health and see if better water access actually improves child health or not. For example, reproductive health, literacy and education of women, head of the household, all this kind of information is available. Child protection, child labor is inside there, and how child is treated at home. HIV/AIDS, access to media. Access to media means TV, radio, computers, and so on. Then subjective well-being is, are you happy or not on the scale of 1 to 5? Adult healthcare, socioeconomic development, and so on. So you can see clearly there are several variables at micro level that you can find in this mixed data set. So this is for Pakistan. So this is I think it's mixed 5, fifth round. So if you find mixed 5 for any other country, you will find more or less same kind of indicators with similar coding methodology and so on. So they are very much standardized and easy to use. But even after that, if they are pre-cleaned, you still need to do some cleaning, and this is what we are going to do today. So what is Stata? So Stata, I will not read through all this. You had a session yesterday also on Stata, so you might know all this already. But Stata is very powerful data analysis software. Mostly it is famous for data manipulation and econometric analysis. So and it can handle big data as well. So manipulation of data, merging large data sets together, and then doing econometric analysis on that. Stata is very good at that. And so this is why you will find this software not only in academia, but also in industry. So World Bank uses it. And you might find in some of the job posting where they are asking for economists or research associate or something like that, they usually ask for expertise in Stata. So it is very widely used. So if you develop a skill set in that, then it is expected that it will be used not only in academia, but also in industry as well. Some of the advantages of Stata, it not only has point and click system, but also has a command syntax. So whatever you do with point and click, meaning you go to estimation, you click OLS and define variables and so on. When you press OK, it gives you the result, but also in addition, it gives you the command that was used to generate that result. So if you understand the syntax, then next time you can simply write that command instead of going point and click every time. So if you are if you have a really big project where you have several hundreds of regressions to run, and then you have to compile them all together, it is not really recommended to do it point and click. So once you know this command, how to use certain variables to do certain analysis, you can replicate it for other variables as well. Sanddesk is also relatively easy to learn. Of course, coding takes time to understand, but because you can learn from point and click system, it makes it very easy for you to master Stata syntax. Documentation is also fantastic. If you are not, I've been using Stata for more than 12 years now, but still I don't remember all the commands. So I simply type help space, whatever the command is, it gives all the details that I need to know to refresh my memory and to use that command correctly. Very strong support for econometric models, as I mentioned before, and survey data analysis as well. This gets a little bit more complex, so it's just for your information. Disadvantages, in one window of Stata, you can only open one data set. You cannot, like in R, you can open several data sets within one window. In Stata, you cannot. For our analysis, most of the time in economics, when we use data sets, we are usually dealing with one data set at a time. So it's not such a big disadvantage for us. But just to know that you cannot actually open 2 or more data sets at the same time in one window, you have to open a new window for that. Graphs, Stata can make graphs. Simple graphs are okay. But even to make like similar graph as pivot graphs that you make in Excel, it takes a lot of effort to do that. So it is not very intuitive in terms of making graphs. And Stata modelers or the people behind Stata, they are introducing more and more graphs. They are moving towards data analytics side for industry, where they make more and more fancy graphs, but they are not making it easier to make simple graphs, bar charts, and so on. They are much easier in R, for example. Similarly, for tables, you can make tables in Stata, but SPSS is much better in making tables. I will give you an example. I hope that you can see my PDF screen right now. So this is also from MICS. So you can see that percentage of households by house ownership is there. And within that, we have 4 categories. And within that, we have area of residence, Punjab, education, all those kind of things. If you want to do that in Stata, it will take several tables, and then you have to combine them together, most probably manually. But in SPSS, is point and click. So making tables is much easier in SPSS in that sense. So there was a question yesterday also in the session related to Stata, whether we should use Stata or SPSS or something. I have added R as well. It's the last point. If you ask me personally, I would say that if you can master R, that is the best option, because it is free, number one. And because of being open source software, it is expanding very fast, and it can create really fantastic graphs. The only caveat is that it is purely command based. So you need to master the language. It takes some time. But if you can do that, then R can interact with LaTeX. So if you're writing your paper in LaTeX, then R can interact with that directly. It can create figures and tables inside your PDF, generating out of LaTeX. And it can also create very nice tables as well. So if you want to just create tables like the one that I showed you in the PDF, then SPSS might be a better option. But if you want to do intensive econometric exercises, Stata might be better. If you want to have many different options using just one software, then R would be better. So I use Stata. That this is my go-to software. But if you are like beginner and starting to do your PhD and wondering which kind of software I should master, maybe R is the way to go. But keep in mind that it's not as point and click easy like Stata is. So very quickly, I will go through the overall layout of Stata. Then we will jump to the Stata software itself and apply some of the commands. So this bottom part that you see on your screen with the blue header is the place where you type your commands. Even if you don't type your commands, if you use point and click method from the top menu of this window, then you will still get some commands in this viewer window, which can be reused using the command window to create the same outcome. What I mean by this, I will show it later. So this is called command window. Once data is loaded inside Stata, it will show all the variables on the right-hand side. This right-hand side section is called variable window. You see the name of it and the label of it. So for example, make and model is the label. I know you might not be able to see it clearly. In the software, you'll see it more clearly. But the first variable is called make. Its label is make and model. So if you write make and model as a variable name, it's very tedious to type it down. So you keep your variable names shorter, but you put a label on it so that you can understand what is inside that variable. So that is the variable label you can see. And also it has the properties window where you have properties of a variable. If this variable is a string, meaning a text variable, or a numerical variable, and so on, you will see all this information in this properties window, and also for the data set that is being used right now. Review window is something you see on the left-hand side, this part right here. Whatever command you execute here, will appear in this window right here. So if the command was unsuccessful, if it could not execute, it will appear red. And if it was successful, then it will appear as a black. So it gives you an indication that actually the command went through when you click enter. And if it appears as a black colored command, then it is something that has been executed. The red means that there was some error. And in this data, you can see this R199 has a hyperlink, so you can click it and see what error actually occurred, but more on that later. Now, working directory, at the bottom of this window, you see there is a path shown, meaning the folder in which you're working right now. It is important because there are two ways of working in Stata. For example, you have a data set stored in your My Documents folder. You could either define the path of this file like C:/C:/ my documents slash blah 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 .dta, and then type enter. You will open your file. Alternatively, you can define my documents as your working directory and simply write use file name.dta, and the file will be open. So if your software is actually inside the working directory, it makes it much easier to access the data files and also save the files in that working folder. If you have many projects going on at the same time, it is of course much better to have different folders for different projects. So then whenever you are working on project number one, you go to project number one folder, make it the working directory, and just start working on it. So I think this is the right time to actually go to the Stata window and practically show you what I mean. If one of the participants could tell me that you can see the Stata window, that will be fantastic.
Yes, it is quite visible.
Fantastic. Thank you so much. So you can see the path right here at the bottom. If you just want to see it, that's fine. But let's see if you want to actually copy this path. So to actually view what working directory is, you could write pwd and press enter. And then it will show you the path, the working directory path that we are in right now. So this is the path that we are in. We could change it. My files are in this folder. This is documents JK workshop folder. So I could change this directory. And to change this directory, I could copy some of this part because my documents folder is also in the same path as the downloads folder. So I'll copy this. And I'll write CD. So I'm changing the directory and inverted commas, paste, and this will be documents. And I will close the inverted commas and press enter. So you can see at the bottom now it has changed to documents. I could also try pwd again and see that my working directory is now in the user folder is documents. But you notice that there is another folder inside this documents folder that has my files. So I just wanted to show you that, for example, even without being in JK workshop folder itself, I could actually access it by being inside document folder. How? So for example, if I want to open this app 1.dta file, which we'll use later on for appending, I could use that to open a file. For example, in Stata, we use the command use, and I could write, keep in mind that we are in documents folder. Now I need to type /JK workshop / the name of the file is app1.dta. I close the inverted commas and then I press enter. So once I do that, you can see that this is black. It means that the command went through And on the right-hand side, you can see the variables are here. They are available now. So in the PPT, I was showing you that if I click one of these variables, it shows me the name of the variable, the label assigned to that variable. For example, H1 is actually the ID for cluster. What is cluster sampling? Actually, this session was covered, I think, 2 days ago. So once these videos are uploaded, you can go through that. So I'm going to skip that because it was already covered. So multiple indicator cluster survey is called cluster survey because they use the cluster methodology for sampling. So cluster ID, and this is the type is byte. So byte is one of the many numerical data types in Stata. Float and integer and all those are also. For example, if I go to this year of survey, it says it int as a type of the variable. It is integer, meaning that it's a numerical format. If I go to GHOH, which is gender of head of the household, I click that, it says string, str1. So string means text. So what do I mean by all this? I can actually go, if you want to browse data, there are two ways of doing it. Actually, you could do this by command as well, but let's start with point and click. So we have data editor browse up here, data editor browse. Then we also have data editor edit. So if you want to manually change data, which is, I would not recommend it because it's prone to errors. If you manually click and change things in data set, it's not recommended. And that's why Stata has this data editor browse option, which is the read-only version, just to explore data, and that's it. You don't really change anything manually. So you click this data browse option, and you can see that this is the data set at hand. So as we saw before, you can see the properties panel here as well. If you click this GHOH, it says string, and you notice that all the variables that have text value in that in there, it is represented in red color. The red color is for string. So this one is string HH6. If I click that, it is also string. The number after str represents what is the length of the string. So maximum how far it can go. So str five characters. For district, it's still string, but it can go up to 10 characters. So str10. So these are numerical variables. These are text variables. So this is what I wanted to show you. Okay. Am I missing anything? I think not. Okay. Going back to, okay, you can also save the file. Maybe we can do saving later on because we're just starting. So you will use a similar kind of methodology to access files within folders for saving as well. So that is the whole point of mentioning save in there. We use example of using a file. You can also save the file using similar methodology. So if you have a main folder, have 5 different subfolders in there, you just keep on mentioning the folders and ask Stata to save in those subfolders. So it's very easy in that sense. Now, we have something called do files in Stata. You have heard about this already in previous sessions. Do file is a collection of commands that you can use to actually run regressions, do data manipulations, and so on. Whatever you are seeing here, not here, sorry, here on the left-hand side, this can be saved in the do file, and you can execute it later on. In one click, it will execute all the steps that you have done. So we can, I think, we can already start the do file. You can access it from here, point and click method, easy. So you simply go here, it says new do file editor. So you can click this. Alternatively, you could also use this command called do edit, I think. Do edit is the command to bring it up. But here it is, do edit. But you can also simply click it and open it up. So as I mentioned, you could simply go here and, for example, I keep pressing control on the keyboard, and I copy these commands, copy them, and then I paste them here. Then I can execute the same commands again. So it will do the same things that it has done already, and it will give me the same output. Couple of things very interesting about do file is, so to execute these commands, once if I want to execute everything, I simply go here and say execute. If I only want to execute one of the commands, I either click on the number associated to it and then click this, or I simply select this. For example, I select these two and I click this, it will execute it, for example. As you can see in the background, it executed. A couple of neat features of do files is that, for example, we only have 4 commands and we haven't done anything yet practically, and we still have 4 commands. So if you have a big project, it could go up to 2000 commands. And when you're working on a project, you will remember what you have done. But when you reopen it after 6 months or so, you will not remember what half of the commands are doing. So for that, you write comments for each command. Most of the most important commands, you write comments on them. So to write comments, you can either use double slash and write, for example, show working directory. Yeah. So this could be a comment. So if you execute the entire file, the commented part will not be executed in the do file. So that is the thing. If you can write all the text you want, but Stata will not treat it as a command. If you write it without the double slashes, then Stata will think that you are trying to execute a command, then it will cause an error. Okay. If you have a very long text to write, then there is, if you can write slash star, and to close it down, you write star slash. So within these two, slash star and star slash, whatever you write will be treated as a text. So I will just write text, text, text. Whatever I write is always green because we have this inside of this command here. So it will not be executed as a command. You can write complete text of what you were trying to do with the commands below or above. So it acts as a note for the commands that you're using inside do file. Okay, and so I've covered most of this. And you can also use simple star as well. If you have just one line comments, just type a star and then write a comment on it. That should be fine. All right, I think that's more or less it. And then you execute it as it's mentioned here. Don't need to explain it further. Long lines I've already explained. Okay, now use, I have already shown you how to use the use command. So if you want to open already existing Stata file, you use the use command as we did here. You can also import the Excel files. So how do you do that? Before we actually import it, let's have a look at what this Excel file looks like. I just created a demo file to have some fun with it. So this is the Excel file that I'm going to use in a minute. HH1, HH2. This is the same kind of variables that you saw in the previous file. So I used this Excel file to create app1.dta that we used previously. So this is the Excel file that I want to import inside Stata. So how do I do that? Instead of going to command, we could simply go here, file, import, spreadsheet. Is there a chat? Okay, so if I'm going too fast, I think if I go too slow, then we will cover only 5 or 6 months. So I know this is information overload and it is recorded. So I think it will be useful for you. If you want to ask any questions, you can stop me anytime. But I think if I go very slow, we will just cover the basics of the layout of Stata in 1 hour. I think it will not be useful. So I'm going to go a little bit faster. You can pause and practice later on when it is recorded. If you have any questions, feel free to ask, please. Okay,
Yes,
so
please go ahead, Professor.
okay, thank you. Okay, so file, I go to import, and the first one is Excel spreadsheet. And then from browse, I will go and to the folder where I have this demo data. I click it, and then I open it. Okay, now it is showing me the preview of the file that we just saw. HS1, HS2, and so on. So now I'm going to intentionally make an error. Okay, so I will just simply click OK, and I'll show you what happens if I don't do anything. I simply click Browse, navigate to the file, and click OK. Okay, so I click OK. Now you see that the variable names are a bit shady, A, B, C, D, E, F. So I go to Browse, and I see that it did not consider the first row as a variable name. So it considered it as part of the data set. So everything is now text because HS1 is text, HS2 is text. So all of these are text. So it considers everything as text. So definitely we had to do something else and we messed it up a little bit. So we clear it. So to clear the data set at hand, we simply have to write clear and press enter. So all the variables are gone. So let's do this again. File, open, Excel spreadsheet, go to the same file, and then click open. Now, here you see an option saying import first row as variable names. I click that. Now you see that if I unclick it, it says the variable names go down. If I click it, the variable names come up. So you do that, and then you press OK. Now we have this data set copied, like opened up, right? So when I go to the data editor, data browser, I see that the numerical variables are numerical, text variables are text as they should be. So this is how you actually import Excel files. You can also import CSV files, very similar to Excel as well. And those are here. I'm not going to do that, but just showing you that some data sources give you files in CSV format. So you can also import them in Stata using this command right here. Okay, clear. We've seen save. Let's save a dummy file. It will show us how to save it. Save as. I can simply write dummy and I save it. So as I was telling you, I use point and click method, file, save as, and stuff. And Stata gave me the command for it. This is the command that it used, which is save and the full path of the file and dummy.dta, because this is how I defined it. And you can click, because it's in the review window as well, I can simply click it to bring it back here in the command. If I want to change it to dummy1, for example, it will create a new file, dummy1, using the same command. So even though I use point and click, Stata is giving me the command for it. So you can copy it and maybe paste it in the do file to use later, for example. I paste it here, and I could simply write / saving the file. So next time you open it, you know that this command is used for saving the file, for example. Okay, import limited is CSV file. I just explained it to you. Stata DTA files are Stata specific data files. I don't need to explain that. I think if you have it, if you have Stata installed in your computer, and if you have DTA files, you simply double click it and Stata will open it. So that's as simple as that. Okay, so this is a tricky part. Okay. If you don't understand this, please stop me. I will be more than happy to explain it. So merging and appending is very simple. Merging can be a little bit tricky. So I will be slow. I will explain it, what it means. If you have any questions, please feel free to stop me. Okay, let's start from the merging part on the left-hand side. We have two data sets. One is here, one is here. In this data set, we have data for 3 households, HH, 1, 2, and 3. In this data set, we have income for these households. So this is the whole story of the data set on the left side, this one. On this data set, we have same households, HH, 1, 2, and 3, but instead of income, in this data set, we have information about which household lives in rural area or urban area. So these are two different files. Now I want to combine the two so that in one data set, I have 3 variables. One is the ID of the household, second is the income, and third is whether the household is living in the rural area or the urban area. This is when we use merge. Merge is used when we have similar characteristics of the households. In this case, we have households, so I'm using household. It could be countries, it could be some other entities. Whatever the primary unit of analysis is, if you have same unit of analysis on both sides and you want to combine the data sets to have variables together in one data set, this is where you use merge. So on the contrary, appending means, to give you an idea, I will explain this in Stata as well. It will become even more clearer. But just to have a look at appending, what appending means as contrary to merge. In the first file here, we have data for household number 1, 2, and 3. In the second file here, we have data for households 4, 5, and 6. So imagine you were doing a survey. On the first day, you only managed to interview 3 people, 3 households, 1, 2, 3, and you have a data set for it. Second day, you started a new data set. You interviewed household numbers 4, 5, and 6. Now you have same variables, but different household IDs. Different people you interviewed. Day 1, you interviewed 1, 2, 3. Day 2, you interviewed 4, 5, 6. Now you want to combine them together. So appending it is like merging the data in vertical form. So imagine it in Excel, you have data for 1, 2, 3. Now you are copy pasting data for 4, 5, 6 right below those observations that were recorded in the previous day. So if you are doing this vertical kind of combining data sets, this is appending. If you're doing horizontal, meaning that you have one variable in one data set, you have 2 others in another one, you want to combine them horizontally, the data set become larger horizontally, just to keep in mind, then this is called merging. In Stata, when you are merging data sets, it's not limited to Stata, but this is the context of merging different data sets anyway. You have to understand what 1 to 1, 1 to M, M to 1, and M to M means. So I will try to explain this with the example at hand right now. So we have a data set here which has household characteristics, HHID, 1, 2, 3, 4, 5. So these are 5 households, distinct households, unique ones, and we have information about them. What is the household size of it? So household number 1 has the household size of 2. There are 2 members in the household, and the income level is 100,000, whatever the unit is, rupees, for example. Similarly for 2, 3, 4, and 5. So this is a household level, unique for each household. Unique means one observation per household ID. So you see that 1 is not repeating. 1 is only appearing one time. 2, 3, and 4, 5, unique, one observation per household ID. Now, coming to this side, member data set, same households, but we had 2 members in this household ID number 1. So we have household ID repeating here. So first member of the first household has 10 years of education. Second member of the first household has 2 years of education, and so on. So second household had 3 members. So the first member of the second household had 5 years of education, and so on. You get the point. Notice that we, on the left-hand side in this data set, we have unique observations. So if I'm using, we need to use keys. Stata needs to understand on what basis do you want to merge this data set. Are you going to combine household ID to household ID, or you going to combine member ID to member ID? So Stata needs to understand, for example, we need to tell Stata that on the left-hand side, we have information for households. We need to match that to the same ID. We need to match this household to its members in the next data set on the right-hand side that we have. So we need to have a data set which tells us the household income, household size, as well as information about their members. So when we do this kind of combination, you see that there are, now I'm using the terminology for office data. There are many values of household ID in this column. It is no longer unique. Here it is unique, one ID per household. Here there are many IDs per household, 3 IDs, 2 IDs, because there are many members, so IDs are repeating. In this case, when we combine these two, it will be one to many merge. So we open this file first. We tell Stata that we have to combine these data sets based on this primary key, HHID. So Stata will look for this, but Stata knows if we give it 1:m, Stata knows that in the first data set, ID is unique because we are saying 1. In the second data set, ID is not unique. There are many values per household ID. This is why we mention it like this. 1:m. So merge 1:m is the method we use here to combine these two data sets. If we had two data sets with 1, 2, 3, 4, 5, and also on the right hand 1, 2, 3, 4, 5 unique household IDs in both files, then we will simply use 1:1, because then both household IDs in both their data sets, household ID will be unique, one value per household. I hope that it is clear. Okay, so let's do this in Stata to have a better idea. Let's clear it up. All right. So I will go to so I have this merge one file. So when you have opened a file, the first file that you open right now, and you are going to execute merge right now, the file that is open in front of you, this is called master file in Stata. So the file that is open right now, merge one, for me, this is the master file. And the file that I'm going to merge it with is called using file. Okay, so this is my master file now because I opened it first. And we can have a look what it looks like. So it has 5 variables. And I could also open the second file just to show you what to expect. So it will open in the new window. Here we have additional variable HS7, which is not available in the first one. So this, if I go here and I open this one, so you see that HS7 is not there. So I need to combine this with this file, with this file, so that HS7 is also present in the main file that we have. So what do I do? I have this master file, so I write merge 1:1, because I know that I use the same data set to create 2 files. I know that the household files are unique. And also, I will tell you one more thing to understand the context of this. So this is the house HH1. HH1 here is a cluster ID. Okay. And within each cluster, to imagine cluster, to grasp the understanding of it, imagine it as a neighborhood. Okay. So a street, for example, and there are households on it. It's more complex than that, but just for your understanding, this is the street number, and within that street number, we have many households. So you can see that in street number 1, we have 1, 2, 3, 4, and blah, blah, blah. But when the street number changes, cluster number changes, the household IDs start from 1 again. So this household number 1 is not the same as household number 1 here, because this belongs to a different cluster, right? So if I tell Stata that merge it by household numbers, then Stata will be confused because it sees 1 many times, here, here, and 2 also, 2 here, 2 here, and 2 here. So even though these households are distinct, they are unique, according to the clusters, Stata will not recognize that. So we need to tell Stata that we need to account for both of these things, not only the household ID, but also the cluster that they are in. So you can do both. In Stata, you can tell the software that you can use household ID, for example, as a primary key for merging, or you can give multiple variables. For example, in this case, we can say use both cluster ID and households within them as a unique key. So why is it unique? You can see that the combination of 1 and 1, household number 1 in cluster number 1 is only appearing once. Household number 2, household number 1, cluster number 2 is only appearing once. So this combination is unique. So I need to not only define household ID, but also the cluster that the household is in. So I will say merge 1, 1, HH1, which is for cluster. And within that cluster, we have household ID. And now we have to tell which file is which file is the one that we want to merge it with. So merge 1, 1, HH1, HH2 using, it's in the same path as here. So I can simply copy paste it, copy, paste. But the second file is called merge2 right here. So I will just change merge 1 to merge 2. Okay, and we press enter. So 2 things happen. One is this output, which says that 34 observations were there, all were matched because we combined them 1 by 1. And it creates a new variable called underscore merge right here. Okay, so underscore merge can take 3 values, 1, 2, and 3. 1 is when it could not find the values in the master data. 2 is when it could not find the matching values in the using data. 3 is when everything was matched. So in this case, we did not have any not matched values. So this is why it is only merge equal to 3. We can actually visualize it also. So you can see that the data set has HH7 also now. So we have combined, it still says merge 1 because we did not save it yet. So it is merged 1, but we have merged 2 variable as well. And it says matched 3. So the value is 3 right here, and the value label attached to it is also right here. So this is the combined data set at hand after merging the files. If we had multiple observation on the right hand side, we would use 1:m. I think we can go to mix now and use that. All right, so let's open the household data. So household data of multiple indicator cluster survey is now loaded. So we have plenty of variables, lots of observations, more than 53,000 observations for Punjab province in Pakistan. And all the interesting observation variables are here. So if you want to search through the variables, you could simply like, for example, water. It will tell you what kind of variables are available related to the water used by the households, and so on, water treatment, and so on. Here you see that the household and the cluster IDs are unique because this is a household level data, remember. I want to merge this with children data, okay? So I will open the children data and show you that why household IDs are not unique in children's data. So this is child's data. How do I know? It's mentioned here, CH. You see that This is the cluster ID, for example. And within that, we have household ID 10. 10 is repeating. Why is that? Because this is a children's data. So it's quite possible that in one household, we have multiple children. And children IDs are different here. See? So 6 and 7 are the child IDs. So they select some of the children for data. So they could be 1, 2, 3, 4, 5, but we are not interested in them. The data which is available right now is that the children, there are multiple children in one household. This is why household ID is repeating. So if I tell Stata right now that merge household ID with children ID, household data set with children data set using 1 and 1, it will not be successful because we have repeating HS2 values. Let's try that. Let's close this thing. Okay, we are in here. Okay, now we try this. HH1, HH2 using. Now we are inside the HH data because we use this thing. So we are no longer in the dummy data right now. We are in the mixed data. So we use 1:1, and we use, I'm combining this household data set with child data set using 1:1. Let's see if it works. So it says variables HH1, HH2 do not uniquely identify observations in the using data. Using data is the one that we are merging it with. This is the child data. And as I showed you before, because there are multiple children in one household, household ID is repeating. So what I need to tell Stata right now is that we need to use 1:m. 1:m method for merging household data with children data. Let's see what happens. So this is what happens. It says, okay, there are 42,000 observations that were matched. So merge equal to 1 means there were 28,000 observations in the master file, meaning household file, that were in master, but not available in children file. So this could be, the reason could be that there are many households in which there were no children. So of course, those households are missing from the children data. So these are not matched ones. These are the matched ones. So now we have children's data combined with household data. Why do we need that? If we simply open children's data, we do not have household characteristics, for example, what kind of water they use, if they use water treatment, whatever. So household level characteristics are in household file, child level characteristics are in children file. We combine them together to have a combined data set, which is right here. So household characteristics, and then we have, so if I write, we have water, so I wrote water, so it has water related variables which are from household data set. And if I write diarrhea, for example, so child had diarrhea is also there. So it matched each household with the children inside them. Now we can compare or match the household characteristics with the children characteristics. This is how merging works. I think I'm really running short of time, so I will skip the appending part. How much time do I have, if I may know?
Our session will be running till 5:30.
5:30 Indian time, right?
Yes, so we are having 40 minutes.
Oh, fantastic. Okay, fantastic. Okay. All right, then I think we can do the uh, appending thing as well. Let's do this. So if anyone has any question related to merging, they can ask right now. Then I will show appending, and then we will go to changing variables and labeling and stuff. Any question on merging, please?
Right now, I suggest we quickly jump and try to finish. Then at the end, we can take all the questions. And the
Okay.
session is going to in recording, and later on they can, at their own pace, they can learn.
All right. Thank you. Silence either means nothing is clear or everything is clear. So I hope everything is clear. If not, then I'm also available later on. Okay, let's do the appending exercise. So what I'm going to do with appending is I'll show you both files. So this is a similar file that I showed you before. You can see that the cluster ID is only 1 and 2. In app1 file, dummy file, we have HHIDs 1 and 2. In app2 file, I'll open that as also. Same variables. That is the difference between merging and appending. Same variables, but we have HH1 equal to 3 here. So what I want to do is I want to add this HH13 inside this file, in which I have HH1 and 2. So as I was mentioning before, imagine that you did 2 interviews yesterday, you did 1 more today, and you want to combine these 2 files together. This is where appending comes in, because variables are the same. You just want to add more data into it. Okay. All right. So where did I open the app1 file? Too many Stata files open. Okay, here it is. So we used app1. We can, appending is actually relatively simpler as compared to merging. So you can simply say append using. So again, master data is app1. I'm using app2 data. I'll just simply copy paste the path because both files are in the same path. I simply changed app1 to app2. So I'll show you before appending, I have HH1 ID 1 and 2. And let's see if this goes through. It does go through, it is black. So I can check the data now. Now I have 1, 2, and 3. So we have added more data below the original file, which had HH1 equal to 1 and HH1 equal to 2. So this is what appending does. All right.
So in appending, we are not getting the signal as in data browse or merge. We have received that another column where it was showing us that your merge is successful and created the green signal. Where in append we are not getting such additional variable in the data. Right?
I did not understand the question. I'm so sorry.
Yeah, I am asking that in merge we got one more extra variable in data set.
Yeah.
And it showed that you have successfully run the message in this command.
Yeah.
While in append, such thing didn't happen. While in append, we are not getting that anything extra in data file.
We get more observations in appending.
We get yeah.
Yeah.
Yeah, we have received more observations as we have just observed both the data files before we have run the merge command. But we are getting extra, column, which is giving a signal as you have done it. But in append,
it is possible that in the using file you have more variables, but when you combine, let's say in the master file you have 5 variables, and you are appending it, not merging it, you are appending it with a file that has 6 variables. So because the 6th variable is not available in the first file, the Stata will still add that variable in the combined file, but it will be missing for the first 2 cluster that were already available. You understand what I mean?
Yes.
So
I got that point. My query was that we are not getting extra,
Okay. All right. Okay, this is done. This is done. Okay, yesterday also there was a question about getting this error that we got also, that the values are not unique. So values are not unique. This error can occur in at least two ways. One is that there is actually this is by definition of the data set, how it is constructed. There are duplicates, as we saw in children data. We have household IDs repeating, so there are duplicates of household ID. So it is genuinely not unique. This can happen, and with one column merge, we can solve that problem. But it's also possible that there are missing values in the key that you are using. For example, household, if you use household ID 1 as the key variable for combining two data sets, and in one of the data sets we have household ID not numeric 1 2 3 4 5 and then some dots 2 3 4 dots. So even though numerics are unique 1 2 3 4 5 6, but if there are 2 or 3 dots, Stata will consider them as household ID, even though it's missing, and it will treat it as something which is repeating. So missing values are repeating. They are not unique anymore. So in that case, if there are missing values, then you have to drop them and then try to merge it again. So not unique values could also be the result of having missing values in the primary key that you are trying to use to merge two data sets together. Or it could be actually a genuine case, as we saw in the case of merging household data set with child data set. So we saw 1:1, we saw 1:m. M:1 is the reverse of it. M:m is something which should be avoided. M:m is like randomly, it kind of seems like randomly putting everything together. I will not go too much into detail about it. I will share the slides with you later on. But if you see this example, we have a student ID. One student is taking math and science, second student taking only math, third is taking English. Now we are merging this with the teacher ID, the teachers who are teaching these subjects. So we will be using this as a merging ID. This will be our key on the basis of which these two data sets will be combined. So it tries to match everything with everything. So student 1 is matched with math and teacher ID. Student 1 is again matched with math, teacher ID 2. So in some cases, this permutation and combination will make sense. But in our cases, most of the times, avoid using M:m merging, because in most cases it will turn out to be useless. So unless you are absolutely sure that this is what you want to do, because it will just create permutations and combinations of different household IDs. So be very careful when you're using M:m. Option is there, but I don't know if you should use it. Okay, exploring data, tabulate and table. We used it yesterday, or I think in one of the sessions, so I don't need to repeat it. Summarize, maybe I can run one summarize command. I could simply write sum, and I could say year of survey, or maybe we could put all of them together. So all of them here. So it gives us a summary of data set at hand, how many observations are there. Z is showing 0 because these are not numerical variables, so you cannot create a summary out of a text string variable. That's why it's 0. And it shows you minimum, maximum, means, and standard deviation. So sum is short for summarize. You could write summarize also. It's up to you. And you can get this simple descriptive statistics using this command. Tabulate and table was very well covered yesterday, so I think we don't really need to go for that. Tab, maybe I could run it once. Where is it? Okay, I could say tab, and I could just do this. It will tell me that 9 are female, 25 are male. So this is the gender of the household head. This is how you can use tabulate command. You can also use two variables to cross tabulate, but I think it was very well covered yesterday, so I don't think we need to go through that. All right, so generating new variables, replace and egen and so on. Let's go into that. Now we are going to data manipulation, data creation, and so on. Okay, where is our merged data? Let's get rid of this. This is our merged data. So first thing I will do is, because these values were not matched, I will just drop them. So if you want to drop some values from the data set entirely, you simply write drop. If you write drop and a variable name, actually I have to remerge it because I cleared it. So I will do it again. Wait, do this, this. Okay, now we are back. So if I want to drop a variable, I will simply write drop, and I could write, for example, age6. I will simply enter it. It will drop the entire variable. If I want to drop some values, because some observations are not matched, so it doesn't make sense for us to keep them, because these are the observations for which we have data for households, but nothing for the children, because these observations were in only masters, not using. Using was our child data. So I will drop if underscore merge is equal to 1, double equal to 1. So this is the syntax. So if I'm defining if condition, I have to write equal to twice to make it exactly equal to. If I write simply equal to in mathematical terms, it means approximately equal to, which does not work in this scenario when we are saying if this equals to, exactly equals to 1. Why I'm saying 1? Because here it says, for the cases where household data is available but children's data is not available, this underscore merge variable that was created because of merging right here at the end is equal to 1. So in all the cases where household data is available but children's data is not available, this variable equals to 1. So I will drop if underscore merge double equal to 1. I do that. 28,982 observations were deleted. And this is the exact number that we wanted to delete. So now we have the data set with households with children in them. So everything else is removed. Okay, so if I want to create a new variable, I could write gen equal to 1, for example. No, gen create a variable, for example, y1 equal to 1, for example. It will create a new variable y1 right here. I can browse it to see what it is. Because I said y1 equal to 1, it created a new variable, which is 1 for every instance. So for each observation in this data set, this y1 equals to 1. You can also create a variable based on the variables available already. For example, this is mother's education. I could tab to see what is going on in there. It says none, preschool, primary, middle, secondary, higher. I also want to browse to see if you can see that this is showing us text, but it is quite possible that actually these are numbers, but there is a value label assigned to it. To see that, I will go to, I could also use sum ME level. If it turns out to be 0, if the summary is 0, it means that it's a string variable. If there is some observation, see, it is a numerical variable. So I could also see it alternatively by browse ME level. So it is telling me that this higher, notice that this is blue. So if it was simply text, it would be red, but it is blue. Means that if I click it, you can see here that there is a numerical value behind it. And there is a label assigned to it. These are called value labels. In the beginning, I was telling you that if you import a SPSS file inside this data, it can mess up the value labels, and this is the value label. So there is a number and there is a value label assigned to it. So I need to see, if I want to create a new variable out of this, I need to see how these value labels are defined. For that, I would say label values. What is the value label assigned to it? You can see here is ME level, ME level. So the variable name is also ME level, and value label is also ME level. So I want to see this. So I would say label list ME level. So this is telling me that if mother's education is 0, defined as 0, it means that she had no education or preschool. If this is equal to 1, it is primary education, 2 is middle, 3 is secondary, and so on. So this is telling me that these are the labels assigned to the values inside this ME level variable. Okay. So if I want to create a new variable out of it, for example, if I want to say, if mother has primary education, then I need to have a new variable primary, which equals to 1. So I will say gen primary equal to 1 when? If ME level double equal to 1. So if ME level equals to 1, it means that mother's education is equal to 1, which is primary. And this is what I want to denote in the new variable that I create, which is primary equal to 1. So I do that. And now I can browse primary with ME level to see what it has done. So wherever there is primary education in ME level variable, this new variable that I created is equal to 1, primary equal to 1. Then you can change the values inside this also, because we have this replace command as well. I could also use the replace command here. Okay, let me find the right window for it. Okay. So replace primary equal to 0, for example, if ME level equals to 0. So if this is 0, then it is not primary anymore. We could do this for other categories as well. So I say replace primary equal to 0, the variable that I already created, I'm going to make changes in it now. So replace primary equal to 0 if ME level equals to 0, which is none, no education or preschool. I do this. Okay, let me see. See, I use only 1 equal to. That was a problem. ME level double equals to 2. All right, and now we can browse it again. See that when there is no education, primary where variable says 0. If it is primary, then it says so. This is how you use the replace command as well. Rename, I could. Okay, I could rename primary to prim, for example, to make it shorter. Rename primary, and I simply write PRIM and press enter. Then you see that the variable name is now changed. It's not primary anymore, it's prim. As a best practice, I highly recommend that when you want to rename a variable, unless it's absolutely necessary, maybe create a new variable. So if you want to change something inside a variable, sometimes it's better to have multiple versions of that variable. So renaming is also possible, but maybe create a new variable if it is, unless it is absolutely necessary to do it. Label variable, this is we can say label var, because you see that this variable is created, but we don't know what this is. Right now, we are creating an example. So we know this is when mothers have primary education, but when we open this again in a few days' time, we might not even remember it. So label var prim Now I will write a label for it. Mother has primary education equal to 1. So I enter this. Now it says mother prim means mother has primary education equal to 1, meaning that it's 0 otherwise. So it's very intuitive to see this and understand what is inside this variable now. All right, label define. Okay. Label define is used for value labels. So I will tell you how to do this. Label define. What I'm going to do right now is tab prim. It tells me that there are two values, 0 and 1. We know that 1 is primary, 0 is no education. So I will create a value label that which will say primary when the value is 1 and none when value is 0. So let's define it. Label define. We have to give it a name also. So we say prim is prim1 just to differentiate between the actual variable. We say prim1 is the name of the value label that I'm creating. It's not a variable. It's just the name of the value label that I'm creating. Label define prim1. It will, if it is 0, then it says no education. If it is 1, then it says primary education. Okay, so you will notice that there is no variable created here. It's just a value label created in the background. So now I need to assign it to our variable prim. So label values, this is how we assign a value label to a variable. Label values prim, first we name the variable to which the value labels have to be assigned. And then we name the value label that we created, prim1, which was created right here. Okay, we enter. Since the command is executed correctly, it means something has happened. So let's try to tab prim again. So now you see that it's the same table, same values here, but instead of 0 is saying no education, instead of 1 is saying primary education. So now it's very intuitive. Anybody who tabulates it knows what these zeros and ones mean. So this is how you define and assign value labels to existing variables.
Can we, keep the name of the variable same as we have? As
You
we
mean,
have,
go ahead, please. Sorry. Go ahead.
it's actually prim to prim1. So can we keep, while doing the label, we can keep the prim only? So I think
Yeah. So so I intentionally did this because when you're learning it, it seems confusing why we are doing using two variable names to assign value names. So just to differentiate between the two, I said prim1 is the value label, prim is the actual variable. You can use prim and prim both for both. It doesn't matter. It's just to avoid confusion for the participants. Okay, label value is done. Encode. Okay, so encode is done when you want to convert the numeric string variables to assign them numerical values. So what do we have as string variables? For example, do we have anything which is string? Let's see. Let's close it, open it again. Anything which is string? Not in this one. We had our other data set, maybe there we can do something. Okay, here we can do something. All right. So this is the older data set that I opened before, app1. We have some string variables here. So if I click it, it doesn't say any number. It is a string variable. It is a text, so it is showing text. I can create a new variable which can take values of numerical values for urban and rural. How do we do that? We can do this using encode HH6, and I say after comma I say gen HH6, for example, 2, because it's a second variable we are creating out of HH6. So we say HH6, 2. Okay, now I browse HH6 and HH6, 2. You see that they both are similar. One is red, one is blue. But if I click this, it's a text. If I click this, it's a number. So if for rural, it's 1. For urban, it's 2. Okay. And similarly, as we did before, when we click this one, this variable, it says that the name of the variable is this, and the value label assigned to it, which Stata did it by itself because it understood that these have to be value labels. It created a value label called HH62. So if I want to see what these HH62 label values are, similar to before, I'll say label list HH62. Remember, this HH62 is not a variable. This is a value label. So that's why I use different names for when I was creating a value label myself. It says it's equal to 1 when it's rural, it's equal to 2 when it's urban, as we are seeing here. So 2 for urban and 1 for rural, as it's mentioned here. Okay.
So it has automatically, taken the numerical value.
Yeah.
So if there will be more categories, so it can, automatically. So we don't, need to do it manually like
Yes.
we
So
did in previous.
yeah. So it is very useful when, for example, you're doing macroeconomic analysis. You have hundreds of countries and you want to use panel data, and you need to have a country ID. So you have just names of the countries, but you don't have country IDs. So instead of saying 1 for India, 2 for Bangladesh, you simply ask Stata to encode it. It will give numerical values to it, and then you use it in the panel data estimations. So this is very useful for that. All right. Missing values. Okay, so there are two types of missing values in Stata. One is for the numerical value, and one is for the text value. So how do I show this? So if we have a text data, I think it's better if I show this instead of reading the slides. Why one is what? Let me check again. I forgot what I put in there. Y equal to 1. All right. And missing values. Okay. So. All right. So we have here both numbers and text, so this will be easier. So if I want to change, if I want to replace urban with empty values, for example, if I want to replace, sorry for that. Okay. In HH6, if I want to replace HH6 with empty values, then I have to say double inverted commas, empty in, so there is nothing between inverted commas. So I simply write this because it's a text. Okay, so let's say in Stata, missing value for numerics is dot. So intentionally, I'm going to make a mistake. I'll say replace HH6 equal to dot if HH6 double equal to urban. So whenever we are referring to a text, we have to put it in inverted commas. Okay. So if it is urban, replace it with dot, which is missing value for numeric data. Keep in mind that HH6 is not numeric. So let's see what happens. It says type mismatch because I'm trying to do a numerical operation to a text variable. So I will replace it with, instead of dot, I will say double invert. Oh, no. Inverted commas. And then I press enter, you see that this is gone. So the way you treat missing values for numerical data and string values is different in this data. So you just have to remember that. So let's do this for the numerical as well. So we know that urban in this value, in this variable is 2. So I could say replace HH6 2 equal to dot because it's a numerical variable. If hh62 equals to 2 because it's 2. Okay, so now I try this one. Now this is also gone. So for numerical data, I need to put dot as a missing value. For text data or string values, I need to put double inverted commas without anything in the middle. Okay.
In second part of the command, we are using double equal to.
Yeah. So whenever we define if condition, it has to be exactly equal to. Double equal to means exactly equal to.
Okay,
Otherwise, it will not work. Yeah.
Yes, thank you.
Okay, no problem. So keep drop. So drop I partially already mentioned. We can play around with it as well. All right. So if I say, if I want to drop HH7, I could simply write HH drop HH7 and the variable is gone. So it's HH7 is not there anymore. Okay. If there are, let's say, 10 variables in your data set, one of them is, or two of them are useless, you could drop them. Or if you have thousands of variables in your data set and 10 of them are useful, so instead of saying drop 999 variables, writing each of them one by one, you could simply say keep the relevant variables. So if say I want to keep only these three variables, I say keep these three, drop everything else. I don't need them. So I say this and it removes everything else. So if there is a huge data set like we have right now after merging, we have, where did it go? This data set with so many variables, we don't need all of them. So I could simply say, okay, I need these 5. So I place them here, just drag and drop. I say keep, and it removes everything else. So just keeps the relevant variables that are useful for me. Okay. All right. Keep and drop. So keep if and drop if. If you define if conditions with keep and drop, then it will remove the observations. So you will, you can say keep if income is less than 100. So for anyone who has more than 100 rupees income will be dropped, for example. We did one example already, so I think we don't really need to do it again. Sorting is quite simple. Let's see if I can sort some variable. Okay. Okay, so these, as I mentioned before, these household IDs are associated with the clusters that they are in. So 4, 6, it goes up to 20, and then it starts from a lower number again because it belongs to a different cluster. If I wanted to know how many ones are there, how many twos are there, I could sort these by household ID, right? So I could say sort HH2. HH2 is the household ID. I just do this and then look at the data again. Now you see that it goes from 1, then it's 2. I'm looking at this column right here. Then it's 3, and then it's 4. So it sorted it in ascending order. So this is how sort works. Very intuitive, very simple. I think it is already information overload. So I can stop here if you want.
Yes, we can, but I'm having one small question. So, well, for example, we have done labeling to a variable, and we find we have done some mistake. For example, we have one categorical variable, let us suppose education, and we have done the labeling to the education. But later on, we find that we have missed one label. So, in that case, how to correct it?
So this is where do files are very, very useful. So when you have step-by-step commands of doing this data manipulation one by one, importing through Excel, data cleaning and all that, and then you had this education variable where you have made mistake. So you will do all the commands before that identically, and then in this command you will change what needs to be changed, and then you go forward from there. But in Excel, for example, if you do things manually, if you make one mistake and take 20 steps forward, it is very difficult to go back because you're doing everything manually. So this is where do files come very, very handy, because everything that you're doing is recorded in the commands, and you can stop where the problem was and fix it and then move forward. One thing I also want to mention, I forgot to mention, yesterday in one of the sessions, there was a command for directly uh, placing the commands inside do file. So whatever you're doing in the command window directly goes in the do file. It is, I mean, it's a useful feature, but practically when you are exploring data, you are making many mistakes. You are tabulating, you are visualizing, you are browsing. So all these commands will be fed like garbage in the do file. So it's always better to have a log file. There is, I will not go too much detail into that. For example, this is the log file here, right here. You click this, it will ask where to save this. For example, I say log 2 because I have log 1 already there, and save. Now everything I do in this file will be saved in log. So all the output you are seeing in this video, oh sorry, in this window will be saved in the log file. So that will be your dirty history in the log file, but keep the do file clean. Only copy paste the commands that are useful for you. So next time, as you mentioned, if you made an error in creating a variable, you can pinpoint the error, fix it, and run the do file again. I hope it answers your question.
Thank you very much. So now the floor is open. Anybody having any question, quickly jump. And while we are asking our research person to, off the screen, just stop the screen, and so that we can, assemble on the big screen or together. And I
Okay,
encourage
stop the screen.
participants. Yeah. Please, anybody having any question, you can share, and you can ask directly. I think there is. Is it really you people not having any question?
It means nothing was clear. So I think they're waiting for the video then. Okay. I know it's information overload, but yeah. So
Actually, we are having, participants, mix up. They belonging to some, purely social sciences, where they do not need such type of big database analysis. But I am confident there are, many students from economics and management. If they may have taken,
yeah,
good
I think
attention, they could have there could have been more questions.
I think it's also kind of food for thought for the young researchers, because we sometimes get stuck with very traditional topics in economics, and these kind of topics are relatively new, and there is a lot of room for work there. So if you keep on doing the same Cobb Douglas functions and really I mean, traditional kind of topics, there is a high level of saturation now. So I think it's a good opportunity for the students and young researchers to explore these options and use this micro data sets for impact factor paper and so on. So I think they will learn something from it.
So I think we are not having any questions. I think our moderator has left us already because she was busy in other things. So I am taking the opportunity to make a formal vote of thanks. Before that, I once again giving you one more opportunity. If you are having questions, please write. I think in chat something. they are appreciating for the session. How to start do file? There is one question in chat.
Okay. Okay. I can show you. Wait. Easy. So you can see my screen, right?
Yes, sir.
Okay. So here it is. Simple. You simply click this. It's new do file editor. Click this, and it will start the do file. Or you can write do edit. Do edit. It also does the same thing.
So do file question has been addressed. Anybody having any more questions? So that is all of the session. Give me 1 minute. I am here. So dear participants, it is actually of great pleasure and gratitude that I sit in front of you today to share my heartfelt thanks to our Professor Mohammed, for his insightful and detailed talk on how to handle metadata and using the data software. Absolutely, your expertise and ability to convey complex information in an accessible manner have been invaluable to us. Your session was not only comprehensive, but also engaging. It provides us a deep understanding of the subject matter, the practical insights and techniques which we have seen practically be shared with undoubtedly aid us in our future endeavors, especially the young fellow researchers. Thank you for dedicating your time and effort to enhance our knowledge and skills. Your contribution to our learning experience is deeply appreciated, and we look forward to such more opportunities and benefits from your wisdom in future. Once again, I am very thankful to Professor Mohammed Ali for accepting our invitation at a very short notice without any condition, for your exceptional presentation and for your sharing wealth of knowledge. Thanks once again.
Thank you so much. I just wanted to share this one screen for the participants. So you can contact me on this LinkedIn page to take a picture. And I have 5 Stata tutorials, really bad video editing. I must confess already. It's on my YouTube channel, bad video editing, bad graphics and whatever, but it also shows the Stata basics. So you can use this QR code to go to the first tutorial, and there are 4 more tutorials after that. It will be useful for them if you want to. There are some really rubbish videos there as well. I'm sorry for that, but these data ones are quite good, and they could be useful for you.
So we request you also to share your this PowerPoint presentation on WhatsApp or email so that we can circulate to the post.
Sure.
So with these words, we are now concluding the session as our participants are very tired. So if they can, quickly on their camera quickly and taking photos, and meanwhile you are also asked to bear this session.